Okay, maybe let's start. So spoiler alert, this is the updated talk from Salt Lake City KubeCon. If you've been there or seen that, it's time to walk out now. If not, let's dig a bit into generic control planes and KCP. And let me start the timer. So I'm MJ. For the last 5 years, I've been interested in control planes, Kubernetes control planes in general. I maintain quite a few projects related to control planes, and I do some other stuff, including work and some side gigs, but everything kube related. So, cool. Agenda for today is generic control plane. It's a bit of generic concept and where we're trying to drive the community, KCP, and because it's a deep dive, KCP components and multi-regionality. And how many of you know like standard Kubernetes architecture? Can you give me a hand raise? Like controller manager, etcd and everything. Okay, so when I start talking about KCP components, have in mind Kubernetes architecture. Like try to draw your own conclusions, what the difference is, and I will try to tell why we made these decisions. Cool. How many of you know KCP? Like how many interacted with it? No, okay, it's a pretty new kid on the block. So let's get into that. So what is generic control plane? It's a term which basically was introduced in KEP 4080. The too long didn't read, it's a new code path in Kubernetes code base, where most of the heavy lifting was done already in 131. So it means it's usable, it's there, code was split. Like you didn't felt it if you're a Kubernetes user, but now you can use it. The missing pieces is generic control plane, staging repositories, so this might come up at some point in the future. So reality is, it's not pretty yet in a code base in general. Most of the things are there. If you know where it is, it's quite a powerful tool and I will show it. If not, you and I talk and I will show how it is. So what is Kubernetes generic control plane, or generic control plane as we call it? Your generic control plane could look like this. It's an API surface with fields and looks like Kubernetes itself, but it's not Kubernetes. It's just an API server. So if you're building something like configuration management as a service, or secrets as a service, and you want it to look and feel like Kubernetes, you want your Argo CD to talk to it, you want other toolings to talk to it, that's how it could look like. Or it could look like this, where you have now maybe need for all the bells and whistles in Kube API server, RBAC, certificates, events, leases. The idea is it's modular. Now instead of what you're getting from normal Kube server, which is usually something similar like this, you can pick and choose. So what it allows, we have this wrapper, which is 0.2, basically to start for you to play around. So code base in Kubernetes in KK repository allows you to instantiate specific APIs and only pick and choose the components from there. So, okay, show me the code because this is deep dive. We're not here to basically poke around. So first of all, to understand these things, you need to understand how Kube API server is constructed from the code perspective. So there is this chain. If you ever mingled with a Kube code, this should look familiar to you. We have options. Once we're done with options, we complete them. You have a config. Once we're done with tinkering with a config, you complete it. Server, pre-run, and run. So between these steps, you can change things and modify your API server to do some things differently. And it's more. Internal server consists of many different servers inside. It's like onion. So if options are basically all your flags, all your parameters you're passing in, where config is the informers, clients, like authorization layer, but nothing running yet, still static. And after that, the last stage, the server, basically is when we start running it. So before 131, just a spoiler alert again, that everything in Kube was like this. Like if you touch CLI or some other components, controller manager was there, with exception of Kube API server. After 131, the code was refactored and the same pattern is there. So if you know this, you will get familiar with a code base. Like you see this and you know in what stage of the life cycle of a API server or component you are. When it comes to code, this looks like this. It's basically an onion. Means first in, first out, FIFO. Means the component you loaded first, basically first in, last out, sorry. So the component you're loading first will be called last. So normal Kubernetes API server looks like this. You load a not found handler, you load an API extension server, and you see not found handler is loaded here. So API extension server is responsible for your CRDs. If you don't have this, you don't have CRDs in your cluster. Second one is controlplane API server, which is configmaps, secrets, RBAC, all the core stuff. If you don't have this, you don't have configmaps and secrets. And at the end, you have an open API services aggregation server. So basically what it does, it loads into the chain. So this is a bit different representation of this. So in a generic control plane world, we poking this concept of batteries. We map each and every feature component which you might want to use. We call it a battery. And this is where we are. As I mentioned, if you don't want CRDs, you basically don't need the API extension server altogether. It's an unneeded chain in your request path. So in the end, it's a pluggable do-it-yourself Kubernetes-like API server. Buzzwords. Okay, so a bit of demo. There will be 2 demos if I want. So there is a KCP dev generic control plane repository. If you build it there, you run go start, 1, 2, 3, ready. Means it's so quick, you basically in 3 seconds of my loaded laptop, you can get something which feels and looks like Kubernetes API server. So now you can point your tooling, it works, everything is out of the box. Or you can run something like this, where we're saying everything, same 3 seconds, and now you're getting this. Means it's a quite simple way to get something like something which feels like Kube but is not Kube. And if you notice there, example above, there is no nodes, there is no services, there is no endpoints, there is nothing workload related. So for those who heard about KCP, you might wonder, like, what's the difference? Like, what's the difference between GCP, generic control plane, and KCP? So think of this. All this picture here is generic control plane. So every time I talk about generic control plane, I have everything here in mind in the head. So what you want to have is basically, you have generic control. What you want to have many of them. Because anybody who dealt with custom resource definitions know that as soon as you let second user in your cluster to play with your CRDs, you kind of have a challenge. How we solve it, we put a GitOps in front of it. So in a KCP land, we did this basically. So this is KCP control plane. We make many generic control planes, and now you can have them in a single binary and a single instance backed by the single etcd. And we called it logical cluster. So logical cluster and generic control plane, they kind of synonyms in a following up. On top of that, when you have many of those, when you need to have more of them, we introduced the concept of shards. And shards doesn't exist in Kubernetes. In a KCP land, we do. Means every of these logical clusters, they represent a virtual cluster in a way. It feels and looks like API server, but it's basically backed by the single binary. And they can be reachable by unique URLs. So from the user perspective, they don't see a difference. And what KCP does in addition, it adds some bells and whistles to manage APIs, which is like API exports and API bindings. And there is many other talks about that. If you're interested, just Google KCP in YouTube or Google, and you find those talks around. So if you played or gonna play with KCP, you will find the term workspace. So logical cluster is this unique hash you would see basically there, represents a basically etcd key, how we split tenants. Workspace is concept we implementing on top of logical cluster. So class inheritance, like standard code inheritance thing, it's just something like that. But what it gives you ability to nest workspace together. So workspace can create a hierarchical relationship between them. So in example here, workspace A can contain inside of it a workspace C. Workspace B might be independent. And it's very similar like Linux file system. You have a directory tree, and your file can be a device or something else. It doesn't need to be it can be many things in a file system. How does it look like? If you execute vs3 command, you will see something like this. Every of these are workspaces. You get a logical cluster and says like this logical cluster name root is accessible via this URL. You can change them. You get a different logical cluster unique key, which is basically backs the virtual generic control plane. And we kind of represent it in architecture. So long time ago, KCP had this concept of transparent multi-cluster and workload management. We get rid of that, but we still had a question like, what about workloads? How do I see my pods in the KCP? You don't. But what we can do now is because the similarities to the file system is so close, we can mount things together. So instead of taking here a workspace, which before was a logical cluster, we can mount something into that. So you have the same structure, but now instead of the workspace, same logical cluster, like workspace is built on top of logical cluster, but that doesn't mean it must be. Workspace can be something else, in this case, a mount point, an NFS, a fuse, or in this case, a cluster. So think about this, that like same way how you mount a file system, you can mount clusters. How did we do that now in the implementation? I will show a demo, but this goes a bit to the architecture of KCP. Your KCP architecture, if you build something like this, if you build something in production, would look like something like this. You have many shards, many TCDs, and you have a front proxy. So front proxy knows everything where every component lives. Think of Nginx for your kube cluster, but now it's for the virtual clusters, for every tenant in your system. And if it's a mount point, it just routes the traffic somewhere else. If in the API layer, basically, you have a kind workspace. And this might be, if you're looking to this and thinking like, what the hell he's talking about, I'm going to show in demo a bit, and maybe seeing this in action will be easier. And all the code is in open source. You can play around. But now what you can do when you create a workspace, you can say my workspace is backed by vCluster, backed by NFS, backed by NetApp, like synonyms. And the vCluster object, custom resource definition, is basically tells where to reach it. In this case, B would be a mount point. You go in and you would see everything what's normal Kubernetes cluster would look like. So you kind of got traffic routed to the real cluster. You go back, you can say kube cluster, which is basically implements the mount point. It's like your backing technology of that. So that's a change now from the previous one. So now basically in a spec, it looks like this. And I'm rushing a bit because I want to show more in action to see how it is. So in the end, what you can do, you can basically swap a logical cluster with some other implementation under the hood. Okay, so components. So front proxy, as I mentioned, it acts like an analogy would be Nginx for your applications, but that would be for every workspace, every logical cluster. How it does, in a Kubernetes terms, it's a Kubernetes controller which watches everything, every shard, every deployment out there for your KCP installation, and builds and indexes for the logical clusters and workspaces. Same as Nginx watches for your services and builds request traffic routing rules. This guy builds where your workspaces lives. So this means when you have many KCP shards, you have a single entry point traffic to get routed. So we solved the routing problem. And after that, we said, okay, there is a challenge how you share a data between many shards. And that's a linear scaling problem because you don't want every shard to have a data of every other shard because that would be non-scalable. And you still want to have a concepts like sharing APIs or sharing some access controls between the shards. So KCP cache came into picture. It's an eventual consistency. It's, again, just yet another Kubernetes operator. But what it does, it replicates some of the data from every shard into the shared storage. And that data allows us to do API mappings, like share APIs, share RBAC in some ways, some other rules. So having this, we can start building something like this. Now you can cache caches together and having local cache and global cache. And picture like this is not new. Like for everybody, if you ever touched, and I bet you did, either any of the 3 big cloud providers, you talk to their control planes. The difference is those are proprietary, implemented by specific cloud providers. But when you're talking to the central API, it gets routed. Like example, in Azure case, you talk to the single endpoint, it gets routed to one zone, like West Europe 4 or West Europe 3 or something like that, but you're still hitting a single endpoint. And all these components basically are there, but not visible for us. So all this stuff is different from Kube. And hence, if you want to program it to it, if you ever wrote an operator, it's a bit different. So this was not there when the original presentation was done. So there is a new project now under Kubernetes 6, is a multi-cluster runtime. So anybody familiar with Cluster API? Cool. So for those who don't, Cluster API has this concept of, there is a Cluster API like as a core, and you have a providers, like a Azure Cluster API, AWS Cluster API, means they comply to certain standards and they are provider. So this is an attempt to do similar for the controller runtime, where now you can do a single controller runtime loop and implement many providers. In this case, KCP provider, kind provider. And if you're interested in this, there was a talk in London KubeCon where this was introduced. But the idea is, this allows you to take your existing controller runtime operators and make them KCP aware, make them multi-cluster aware, multi-cloud aware. And what it abstracts you to, like in a KCP land, when you have many shards and you share APIs, so API export is API contract. You as a provider publishing the API saying like, I want to give the service full to every shard. And the consumers can be on any shard in any logical cluster in any workspace. This ends up in many URLs which points to the individual shards. And multi-cluster controller runtime allows you to have the same controller code reconcile which you had before, but now it can talk to this machinery basically. And I know I'm jumping so many levels here. So if you're interested, URLs are down there, and there is examples and demos. Just play around with those. OK, so I kind of rushed through that. So now a demo stuff. So this one is killed. So let's go into the normal one. So I'm starting a KCP instance, and I will start a mounting proxy. So what I have now is like, I'm going to just have 10 minutes, so I have plenty of time. So I have 2 workspaces in my main tree. So I'm talking now to the KCP instance. It's a single URL. You see all of them are backed by one. So example, I can go to use providers, get workspaces. Inside the providers, I have another workspace called mounts. So I basically CD folder into the different logical cluster. CD mounts. So use and mounts are synonyms like aliases. I don't have anything here. If I do logical cluster, I have a logical cluster which backs now this particular workspace. The beauty here is now, like I'm jumping these folders, these workspaces as I would be jumping folders. You don't need to give that to the users. The user can have only this URL somewhere in the notepad file on kubeconfig file and talk to this virtual server, and he doesn't need to be aware of everything what's there. Because like you just create role bindings, nothing here, maybe there's cluster ones. Yeah, so there is like workspace admin. Means because it feels and it has all the machinery of Kubernetes, you can hand over these workspaces to every user individually and basically isolate them at the API server layer. So what I want to show here is API export. So API export, as I mentioned, is an API contract for this particular, from this workspace. And in this case, what it says, this API export exposes mounts.contrib.kcp.io, which is kube clusters object as a CRD and mounts vclusters objects as a CRD. So and it has a URL. What does it do now? So if I go now into VS consumer, API binding, here we go, and I say API binding get, I see that basically consumer accepts an API binding, and you can have many consumers of the similar one export. This means now instead of copy pasting, like if you would have something similar built in a vCluster manner environment or some Kamadi or other multi-tenancy isolation stuff, what you would need to do, you would need to copy paste the same CRD to every vCluster out there or something like that. In here, you bind as a contract saying, as a user, I want to use your like objects, which are basically kube clusters and vClusters. And if I do get CRD, I don't see them. But if I do API resources, I will see them somewhere here, like a vClusters object. So sometimes it's hard to grasp like this concept of basically it's API sharing primitive in a Kubernetes ecosystem. And I mentioned mounts. So example here I have, let's do get VS. I have a kind cluster. Let's create one another workspace called Bob. Now I have workspace Bob and a workspace kind cluster. And you see the different URLs. And the URLs comes from that front proxy, which I mentioned before. Because this one is clusters root consumers, this lives inside of one of the shards. If I do go to use Bob, API resources, my API surface is way smaller. Now, if I do get VS Bob, YAML, example, I would see that, okay, URL is something internal, cluster type this, there is internal machinery. But now if I get kind cluster, I will see that it's a mount point implemented by the object kube cluster and backed by some random big URL by getting the object kube cluster, basically, which analogy would be my storage provider NFS, but basically in this case it's a cluster provider. So kind cluster, and now I do get pods. I see pods. Because what I did, I basically with the picture, remember the picture when the traffic goes through them for proxies, a mount point component and route somewhere. So I jumped from KCP to them different cluster. So we can do a bit more funky things. Back. I'm gonna create a vCluster object. Get pods. And I can see now vCluster example is getting provision here as a pod. And once it wakes up, that basically front proxy Nginx of KCP land will notice that there is like vCluster somewhere running and starts routing traffic from there. It's, again, it's a concept which are not very familiar to people coming usually from Kubernetes cluster land. So if you're interested in this, all the code base is in KCP contrib repository. So to summarize everything what you've seen, KCP itself is not a product. It's not something like Argo CD or Flux or something which you can pick up and run with it, basically off the shelf. Think of this more like a Spring Boot. You take it and you build something. So, but what you do, it allows you to build this control planes things which looks and feels like Kubernetes. So, like a CRDs in Kubernetes, when people build CRDs, they didn't told you that like you can do CRDs only for Nginx or only for traffic routing. You can do anything you want as long as it fits in the YAML basically and you can implement it. So same here, as long as it fits the control planes pattern, you can build what you want. KCP doesn't provide compute, but as I showed, you can mount it in a ways, and if you are more advanced, you can even do a more advanced mounting things. And there was I mentioned transparent multi-cluster aspect of trying to achieve the compute with KCP, but now that's not a goal. So in general, I understand that this might be a different paradigm shifts. So talk to me if you want to know more. We hang out at KCP Slack, KCP Dev. We're quite friendly community. We don't bite. Code is here. We are CNCF sandbox project working towards the next layer. And with this, we still have time to questions. Anything? Going once? No?
Could you give me any kind of like real world use cases? Like where would you use basically and how would you use it?
So
In practice?
in practice, I can tell you about what certain people built on it. So because the CRDs are so flexible, you can add anything you want. So like you can create a CRD which is pod or a deployment. So you take a deployment from Kubernetes, rewrite the YAML into the CRD, and you have a deployment. Means if you take your existing deployment from Kube, replace potentially kind and API, it just works. So people created this service where developers can deploy applications. They don't see pods, they just see deployments running, non-running. And after that, we write a custom controller which routes them to 20 clusters globally. So abstracts the clusters from the user. That case one. Another one would be simple as database as a service. Like anything you can think of as a service, you can kick off in this using 2 hours of Golang coding if you know how to write an operators. And people build, like you need to get access to Jira. Like new joiner gets a workspace and we can provision stuff from there. Like another company did a cluster bot. People come in and every developer gets its own workspace and we request a kubectl create cluster. Each and every Monday morning, they get a cluster. In the evening, they delete a CRD from a workspace and we down. Where the cluster spins, what we do, they don't care. So, and there is more advanced cases. If you're interested in more ones, we can talk about after ones. There is a whole European-backed project how to use KCP and create a provider mesh. Like example, company provides a database as a service, and now another company provides virtual machines as a service. They could talk to each other basically by running Kubernetes-like control planes. And they said there is a whole initiative on this to create a framework so people could do that. And companies like SAP, Kubernetes, Glyso basically are spearheading this in a way. So there is quite a few efforts now to move towards this more Kubernetes resource model-based control planes. It's a harder to answer when it's the same, like, give me examples of what you can build with Spring Boot. It's cool. Any other questions?
We are
out of time.